Here we're going to talk about population studies. This is a social studies study that they do, but I guess even engineers do this kind of studies and scientists. And so what they usually look at, like let's say you are an engineer, uh, you want to build. Let's, let's say, for God's sake, let's talk about you want to build facilities for a community. What kind of facilities are we looking at? Let's say you want to build roads. And so you want to build the roads, you want to know the number of cars that are going to be driving on the road, because wear and tear of the road will depend on how many cars are driving on the road and at what frequency are they driving over the road. And then now when you talk about cars, cars don't drive themselves, not yet, or maybe they do now, but um, usually what you're planning on people driving the cars. So that's when you have to look at population studies. And you will be saying like, okay, well, let's say for now, the population of a certain town, for instance, let me say Nelspruit, let's say it's 3 million. So if that population is 3 million, you go and figure out in the traffic department how many how many people are driving cars in Nelspruit on a population of 3 million. And then when you get that, you take that number, let's say you find out I don't know, maybe whatever number it is, you turn it into a ratio, a percentage of the population. So you figure out, let's say, out of let's say 3 million people, 15% of the population is driving cars. And so now, if the population is projected to grow in the future, it will be reasonable to cater for at least 15% of that population as it grows. Uyohlala unalo 15% wale population, however big it could be. Maybe even if it goes to a million, to a billion, you still are going to take out 15% of that and say, okay, these people will be driving cars. And so in that sense, you will know how to plan the roads, because okay, our roads should be able to take a population of people of this much, and the number of cars that we're expecting to have are 15% of that population, and then you know how big your road should be and maintenance of the road, how frequent you should be maintaining those roads. Okay, now without further ado, let's go to a population growth rate of South Africa per year from year 2000 to 2025. 2025 is the year today. 2000, I was in South Africa. I was counted among this population. South Africa's population was 47.16 million in year 2000. In 2025, it is 64.7 million people. What is South Africa's growth rate in the 25 years? I'm saying in the 25 years because 2025 minus 2000 equals to 25 years. Okay, now we're using the very same equation. A equals to P times 1 plus R over 100 to the power N. Now you already know what we're assuming. What we're assuming, we're saying is that the rate we are going to get it per year. But because these years are 25, so this is more like an average, right? An average per year in the 25 years. Okay, I'll explain it again. So what you do, you take that 64.7, which 64.7 million, it's 64,700,000. Okay, you divide it by, you see now, which is a step, but the step is over here. 64,700,000 equals to 47,160,000 times 1 plus r divided by 100 to the power 25, which is the 25 years. Okay, you come over here, you say 64,700,000 divided by 47,160,000 equals 2. Okay, you know that we'll have to get rid of that 25. So I just introduced the root of 25 here in order to get rid of that 25 over there. So now you see what I'm doing. Now you get like the pattern. Okay, now what you did on this side, you want to do on the other side as well. So the 25th root of 64,700 divided by 47,160. How did I get to the thousands from the millions? It's because I got rid of these zeros, the 3 zeros in the end. In that way, it makes my life a little easy. Okay, equals to 1 plus r over 100. Now, if you put this in a calculator like that, it will give you this. But I know that some calculators don't have the capability to do this. So, but all calculators will have this. So if you put in brackets 64,700 divide by 47,160 to the power 1 over 25. If you put that in your calculate, it's more like you put this so, and then you say yx 1 over 25. So you put this number over here. Then you say yx, it's 64,700 over 47,160. And then you say yx 1 over 25. And it will give you this answer over here, 1.0127. Okay, equals to 1 plus r over 100. Okay, silubisa lo 1 utanganeno, siya minus nganeno. So now r over 100. Over here, we have 0.0127 equals to r over 100. So r way 2 equals to 1.27% per year. So this is an average. What it means is that per year in the 25 years since 2000, the South African population had been growing 1.27% per year. Okay. You can go and check it out in the internet, and you will find that the numbers that you will get there, depending on what website you use, are going to be variable. But the highest probably is going to be 2% per year. So if you get 2% per year, then you will know that, okay, 1.27% is within the ballpark. This is based on the numbers that I got over here. I could have gotten other numbers. Okay.